You know that little box with the blinking lights, probably sitting in the corner of your room? Well, that's your personal gateway to the entire world. But here's the thing, it's not actually just one device. It's more like a team. So today, we're going to demystify the difference between a router and a switch, the unsung heroes that make your internet work. Let's trace the journey your data takes, shall we? Think about it. You type in a website, hit enter, and bam, the page loads. It feels instant, almost like magic. But what is actually happening in those few milliseconds? I can tell you, it's definitely not magic. The truth is, it's a high-speed physical journey. Your request gets turned into a tiny packet of data that travels through a whole series of specialized gadgets. And for the next few minutes, that's exactly what we're going to do. We're going to follow one of those data packets from your computer out into the wild internet and all the way back again. Okay, so the very first stop on this journey happens right there in your own home or office. It's inside what we call your local area network, or LAN. This is just all your personal stuff. Your computer, your phone, maybe a printer or a smart TV, all connected together. Now, to manage all this local chatter, we used to use a device called a hub. And it was pretty dumb. When a hub got some data, it would just shout it out to every single device plugged into it. As you can imagine, that was super inefficient and not very secure. That's why we moved on to the switch. A switch is like a smart traffic cop. Instead of shouting, it whispers. It knows exactly which device asked for the data and delivers it only to that device. It's way more efficient, way more secure, and it's the standard for any modern network today. So how does the switch know where to send that whisper? Well, it uses something called a MAC address. The easiest way to think of a MAC address is like a permanent serial number that's burned in to every single network device made on Earth. It's totally unique. The switch is smart. It keeps a little table that matches each device's unique MAC address to the physical port it's plugged into. And that's how it can direct traffic with such pinpoint precision. Okay, so the switch is the expert at handling all the local conversations. But what happens when your data needs to leave your house and travel out onto the internet? For that, it needs to go through a completely different kind of device, a gateway to the wider world. And this, right here, is the main event. This is the core difference between the two. A switch's entire job is to connect devices together, but only inside one network, your LAN. And it does that using those permanent MAC addresses. A router's job is totally different. Its job is to connect entire networks to each other. It links your private little LAN to the giant wide area network, or WAN, that we all call the internet. And to do that, it needs a completely different kind of address, an IP address. So if you only remember one thing from this whole explainer, make it this. It's so simple. Switches create the network, and routers connect networks. Think of it like this. A switch builds your local neighborhood, connecting all the houses on your street. The router builds the highway that connects your neighborhood to every other neighborhood in the world. This is why they need two different kinds of addresses. That MAC address we talked about, it's like a permanent serial number for the device itself. It never changes. But an IP address, that's more like a temporary mailing address. Your device gets assigned one when it connects to the internet, and that address tells the rest of the world where to send stuff. So the switch uses the local serial number, and the router uses the global mailing address. But wait, there's one more critical piece to this whole puzzle. See, your router speaks the digital language of computers and the internet, but your internet service provider, the cable or phone company, they often use a different analog signal on their lines, so you need a translator. And that translator is the modem. Its full name, modulator demodulator, tells you exactly what it does. It takes the digital signal from your router and modulates it into an analog signal that can travel over the ISP's wires. Then, when data comes back from the internet, it demodulates that analog signal back into a digital one your router can understand. Simple as that. Without this translation, your home network could never talk to the outside world. And we can't forget one last vital component, the firewall. Think of it as your network's digital security guard. It's almost always built right into your router, and its job is to inspect all the data coming in and going out and to block anything that looks suspicious. It's really your first line of defense. And here's a little pro tip. That single box your internet company gave you, it's almost always a combination device, acting as your router, switch, modem, and firewall, all rolled into one. All right, we've met all the key players, the switch for local traffic, the router for connecting to the world, the modem for translating, and the firewall for security. So now let's put it all together and trace that data packet's full journey from your click to the screen. So here's how it all goes down. You click a link, your computer sends that request first to the local switch. The switch sees the request is for the internet.
not another local device, so it forwards it straight to the router, the gateway out. The router then hands that packet to the modem, which does its translation magic and sends it on its way through your ISP. Then, after it gets what you asked for, the response, the website, the video, whatever, it travels that exact same path in reverse, all the way back to your screen. And the crazy part? This all happens in the blink of an eye.
It's really an incredible invisible system, isn't it? A beautiful dance between all these specialized devices, happening trillions of times a day, connecting billions of people all across the globe. It really makes you think. This whole system depends on every single little piece doing its job perfectly. What happens when just one of them fails?